Well, hello there everyone. You've tuned in uxwbill and I'm bringing you along tonight on a no heating call. This is a vacant house that's being remodeled slowly but surely, and so it is that the owners keep the temperature in here just warm enough so that the pipes and stuff won't freeze. Anyway, I came over here tonight to check this out because it's supposed to get down to 15 degrees tonight. It's 41 degrees in the old house. They usually keep it at a temperature of 50. So something odd is definitely going on because by all indications, this thermostat is calling for heat. And I know for a fact that we do have gas present in the house. I also know that the furnace is not running. So let's go downstairs and check it out and see what might be happening. And here, in case you're wondering, is your proof of gas. You can hear it hissing maybe. Let the burner ignite, which it's trying to do. This stove hasn't been used in forever. There we go. So we definitely do have gas present to the property. So now we're here in the basement taking a look at the furnace. Typical 80% efficient Goodman unit. Right there's the energy guide sticker. No, I did not install this, and I don't agree with everything that the person who did when they installed it. But I'll probably come back at a later time and clean this up and make it a lot neater. Take this wire off the gas pipe. I know a lot of people do that around here, but apparently you're not supposed to. Get rid of this old wiring that used to serve the boiler. It's completely dead, but it needs to come out. So let's see if the furnace might be trying to tell us something. I suspect that it has probably locked out due to a repetitive fault condition. You would think the engineers of these things would think about where the LED is on the control board so that you could actually see it through the little window. I can kind of see a reflection of it in there. Oh, there we go. We're getting a blink code. Looks like 3 of them. I think that's a pressure switch error. And I would imagine that after enough failed trials for ignition that this thing is now in lockout. So, go over to the breaker panel and just reset the breaker and see what this thing tries to do. Alright, here's our breaker panel. This is the one for the furnace. Turn it off. Heard the relay on the control board drop out over there. We'll wait a little bit and we'll turn it back on again. Okay, I heard a couple relays pull in, and now the combustion blower or the draft inducer, whichever you prefer to call it, is running. So let's go over there and see what's going on. Our little motor's running bravely away, seems to be doing its job. There's definitely suction through here, which is a good thing. I'm not really sure I like what's going on down here. I don't know why that would be taking place, but there's definitely been some corrosion and degradation. Maybe this is one of those things I keep hearing about why you shouldn't buy Goodman equipment. I've got to admit though, from what I've seen of it, I found no reason to hate Goodman equipment. But what we're doing here basically is proving that the thermostat should be calling for heat right now, and this furnace is trying to comply. If you were uncertain about that and wanted to make a test yourself, and I'm very cautious about giving this sort of advice out, really if your furnace is broken and you don't know which end of a screwdriver to hold, call somebody. Don't get yourself hurt or killed, and certainly don't try to blame me for it if you do. But there are a couple of ways that we could test and find out whether or not the thermostat is actually functional. You need a multimeter for some of these. Just go ahead and turn it on to the AC volts scale, which it is right now. And although I don't have an assistant here to hold in the door switch, I have got a few jumper wires. So what we'll do is we'll hook these up, and there's a couple different ways that you could do this. You go over here to the terminal block where all the thermostat wiring is connected, and there are 3 terminals that are of primary interest here. This is a heating only system, but they're all hooked up for future expansion, which is something I insisted on when this was put in. We're looking at the red wire, the white wire, and the C terminal to which there's nothing attached. And there's a couple different tests that we can do here. First thing we can do is we can stick a clip lead on our white wire and attach that to one of the leads on our multimeter. just like so. Fancy people, myself included, but I don't have them with me, actually have little alligator clips that screw onto the test leads of their multimeter. And you should do this with the power off, just in case you accidentally do short something. Save the board, might save you from popping the fuse, all that sort of good stuff. So now I've got my wiring across terminals R and W. Let's turn power on and I'll show you what happens if the thermostat's actually calling for heat. Alright, so now I've got those clip leads hooked up just like I described, one on the R terminal, one on the W. The theory behind this test is that electricity always takes the path of least resistance, which if the circuit between R and W is closed up at the thermostat and everything's okay there, the thermostat's calling for heat, that will be the path of least resistance relative to the multimeter, which has a very high resistance or impedance figure depending upon what type of voltage you're measuring. So we'll go ahead and power on here, and since I believe the thermostat is successfully calling for heat, we should see 0 volts here, or very, very close to. It might waver and wander around a little bit, but I'll go ahead and depress the safety switch in now. If the thermostat were not calling for heat, you'd probably see somewhere around 24 to 30 volts there. So you'd have to investigate that. Other ways that you can make this test, you can go between W and the common terminal, which for most people probably has nothing on it. So we get our clip lead on there. And this time around, when I energize the door switch on the furnace, when I close the door switch and let the furnace energize, we should see somewhere around 27 to 30 volts there. And indeed we do. That's another indicator that the thermostat is calling for heat. There's a third way that I can think of to make this test. You can always take your clip leads and you can jumper between R and W, which takes the thermostat completely out of the equation. Again, you should turn the power off when you do this, but if your heat or your cooling, if you connect to Y, we're not doing that this time of year, if your heat starts up when you put a jumper here, you better look at your thermostat and its wiring to make sure it's doing what you expect. And if you have the power off, there's yet another possibility, although this does have associated with it some caveats. You can set your multimeter to its continuity mode, again, with the power off, and you can go between the R and W terminals, and if your thermostat's calling, you'll hear a beep, indicating that you have continuity in that circuit. Here's an electrical diagram of this particular furnace. If you decide to troubleshoot your own furnace and you have the knowledge present in order to safely do so, this little diagram is your friend. Of course, sometimes bad things happen to good friends, like this diagram, and you might find yourself having to draw one of your own. I certainly did plenty of that, but that was not where I needed the most help in my HVAC classes. Also present down here is a legend explaining what the various blink codes from that little red LED on the board indicate. We had a code for 3 flashes, which is a pressure switch stuck open. Now, with some older and simpler furnaces, and I say this again very guardedly because you should never bypass the safety in a furnace unless you're going to watch it like a hawk. But older furnaces generally did not care if they didn't see a switch do both a break and a make cycle. This being a newer furnace, it checks for both, and as you can see, it has a corresponding set of error codes. So earlier it looked like we were getting a 3-blink error code. Again, this is not to be taken as 100% gospel because sometimes the board is confused, especially if it doesn't have something like a good ground reference or somebody's been screwing around with the wiring in one of these. But it does at least give you an idea of where you might look for the trouble. So we'll push in our switch here and we'll just see what we get. And right away we've got our error code. Now again, there are a couple different ways that I could test this theory. Just as I did with the thermostat earlier, I could back these connections off a little bit so that I could see some of the terminal here. And I could watch for that switch to close. And again, when that switch closes, it becomes the path of least resistance in the circuit that I'll be making to test it. And so again, if the switch closes properly, the multimeter should read 0 volts or very, very close to. If the switch does not close, I will again see the control voltage that's output by this little transformer right here. So we can hook up and make that test real quick, and I'll show you something else you can do, but only if you're going to watch the furnace like a hawk. You never, ever, ever walk away from a furnace with any safeties jumped out. And I don't think any real furnace technician would, but a lot of slumlords, and yes, that's what I said and what I meant, will do that kind of sleazy thing in order to get their tenants heat for the night. What they don't realize is that sometimes that ends in tragedy. So here are my clip leads hooked up to the pressure switch on this furnace. You'll notice there's an embossed legend indicating what these terminals do when the switch is at rest. It looks like we have a normally open here, a normally closed that isn't used on this model, and the common terminal over here. The common terminal is where the voltage will be coming in, and the normally open terminal is where the voltage will be coming out if this switch is satisfied. Now it should be said that it's not a guarantee that this switch is bad. Sometimes these things can get water in them. But let's go ahead and see what happens here now that I've hooked up the multimeter accordingly and I've made at least a little bit sure that the test leads can't short out on anything. If that switch doesn't make within a few seconds of this blower motor starting up right here, then we will see that 26, 27 some odd volts across that switch, and we'll know that it didn't close. And then I'll show you another test that you can make. That voltage should have dropped out just as soon as that fan got up to speed, and it's still there. So we can be fairly sure, since this is the only thing in this particular part of the circuit, this is the only switch that's a part of this circuit on a simple furnace like this, that switch is probably not doing what it ought to do. Another way we can test this, we can take these leads off of here completely, put them somewhere where they can't short out against anything. And now that we've removed power from that circuit, we can again set our multimeter to its continuity testing range. You can use the audible continuity for this. And we'll just go ahead and try starting things up again here. And if that switch closes, that meter should go beep. And we've got nothing. So it's looking more and more like that switch is probably bad. But there is one final test that we can do, and that is to actually jumper across it temporarily and see what ends up happening. Of course, I just ripped my test lead right off the switch because I only took it off one of the meter leads. So I'll set that back up and I'll show you how that's going to work. Now, as you'll remember from just a couple of minutes ago, this furnace is new enough that it has to see both a successful contact make and a contact break before it will decide to trust what that switch is telling it. So it will not suffice just to take this over here, jumper it, and then push in the safety switch on the furnace. That will not do at all. What I have to do is simulate the actual working conditions of the switch, and we'll see if the furnace goes through with the rest of its ignition-related processes. I don't know if I can get video footage of this because it's going to require that I use both of my hands, but I'll try. I can't promise that you'll see much, but we'll try, okay? How's that sound? We'll put this right down here on the tube that feeds the burners. I don't think that's going to work. And I hope the phone's orientation sensor doesn't go nuts, because if it does, that'll be the end of the video. Let's see if we can get a better look at that. I don't know that I'm going to be able to give you footage of that. But what I'll do is I'll push in the safety switch, and as soon as that blower has come up to speed, I'll go ahead and jumper this, and we'll see if the furnace goes through with its ignition sequence and lights off successfully. Now, there isn't much of a pre-purge on this thing, so I'm going to take the phone and get back here. Our LED light is staying on, which is the normal operating condition. And we are trialing for ignition right now. There goes the hot surface igniter. And there go the burners. Now, as long as I'm sitting here watching this thing, or I'm very close to it, I'm not worried about that switch being jumpered out, because if anything starts to go wrong, I can always race over to the breaker panel, I can shut the gas valve, there's a lot of things I can do. But again, I must stress, never, ever, ever walk away from one of these things where the safety jumped out. And we'll find our front door here and put it on, because our blower is just about to start. Cover that up so it has some semblance of normal operation. I can pull air through it relatively the way it was intended to be done. Looks like this one needs a pressure switch, and I'll just let this run enough for now to warm the old house up to the point where I don't think it'll freeze. Shouldn't lose enough heat in the course of the night. And then I'll get somewhere where I can get a replacement pressure switch for this after I've checked to make sure that there's no water in the tubing or the switch itself, because there certainly could be something like that going up the works. Alright, it's not a perfect solution, but since I can't get the furnace going again tonight, the keykeeper has joined me, and we're doing the best we can to drain as much water as we can out of the pipes of this house. I don't think it'll drop below freezing. But when you're dealing with really clever stuff like this, which needs to be completely rebuilt and redone properly, anything is certainly possible. But I think we can probably get through a night or two until I can get the part. And since that furnace is only 4 years old, I'm going to see if Goodman will by any chance warrant it. They certainly ought to. Alright, so before I wrap this up, and I'm sure some of you have been practically screaming at your monitor saying, "You idiot, make sure that the switch is actually getting the pressure it needs in order to prove." And you would have a very good point. I was getting ready to take this off of here and take it back and see what I needed to do in order to get a replacement. And I thought, well, you know, maybe I should just check and make sure that little passageway up there isn't plugged up, or that this hose doesn't have a split in it. And I was pretty sure of that. But evidently this little passageway up here that creates the vacuum pressure this switch needs in order to pull in and operate was plugged up. So I took one of my little hex keys here after thinking about it and conferring with the keykeeper for a while. And I went ahead and I just cleaned that passage out, and sure enough, now it's running without any help. So never ever forget to check everything. But hey, my excuse is that I'm just starting out in this field. So I don't even pretend to have like a Star Tech badge or anything along those lines. But it looks like we can probably put this thing back together and just keep an eye on its behavior over the next couple of days. And we'll see what happens. Oh, and just in case anybody happens to be wondering, I am going to get a replacement for that hose. Not that I really think it needs it, but it is a little bit loose at one end, so it's probably cheap. Might as well go ahead and get it knocked out while we're here. Thank you as always for watching. And I'm certainly interested in hearing your constructive commentary if you happen to have some. For your own safety, please do not work on your own heating and air conditioning equipment unless you know what you're doing, because especially with gas heat and anything that's electrical, the chance of causing significant injury to yourself, damage to your property, or loss of yourself or a loved one is entirely too real. Some things you really just do need to be a professional in order to properly diagnose and repair.